Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to continue off where we left off last time. So today we're going to actually cover chapter 2 of A Student's Guide to Vectors and Tensors. So I hope you guys are ready for an awesome ride today. So basically chapter 2 is going to be covering vector operations. I did read, well, actually, I probably should say I reread some of the chapter. I covered, like, mainly all the way up to partial differentials. So there were some things that I discovered that I think was kind of interesting. So enough for me yammering. Let me just start the study clock and let's begin, shall we? Okie dokie. And I'm actually using a new, Meetle, which is like, I think like a browser version of like, I guess, Whiteboard that I was using like a couple streams ago. So I thought I would try this out. So let's take a look, because there were some things I want to actually like write in note form so I remember. So I think we should start off with, let's see, 2 point, oh, I don't like that. That looks too thick. So let's go into the pen. Let's just turn the thickness down a little bit, but not too much. So 2.3. And we're doing triple scalar product. I already read this part, but I felt as if I should probably just take note of it, because I thought it was pretty interesting. So we'll make the form a... if I can move this. Nah, I'll worry about that later. Because I was wondering if I could move the sidebar to the bottom bar. Like to the bottom, but I'm not going to worry about that right now. Although the eraser is like a lot more, lot stronger than what I'm used to. hello, Reese Blue? Or Reesble? I don't know if I'm pronouncing that right. Please correct me. But yes, please go ahead, ask. Just call me French guy. Is it okay if I just call you RZ? So that way it's like equivalent to the name you picked? Yeah, of course. Okay, so what do you like to ask? What would you like to ask RZ? I'm just gonna draw this diagram because I think it's like really cool. Now I just gotta like, this is a new note-taking app for me, guys, so I don't know everything about this app yet, so this is a, oops. Do like that. Then we gotta do the dotted lines. Do like that, do like that. Beautiful. Okay, so I have a mathematics problem for you. Oh, okay. I'll try my best to help, but I'm learning math myself, so oh, I don't think I'll be able to answer that. If that's a proof. Oh, thank you for the ad, Andre. Andre-san, yokoso, yokoso. Yeah, I haven't really got into proofs yet. I'm just basically going over like stuff that I know right now, like which is vectors. Like the amount of knowledge I have of math is like up to calculus 2, and I barely remember calc 2, so I'm trying to reteach myself math. Andre-san. Konnichiwa. Are you? No, I am not. I just know I just know a little bit of the language. So plane. Maybe I should have made the back like dotted lines too. I think I won't forget the triple scalar product because like this geographic representation looks really cool. I mean, like, what is your question? Because like sometimes I do have people coming in who know more math than me. So maybe if you put your question up, maybe they can help you. And that way I also learn something about what you're learning as well. Because I love it when people like know more stuff than me, because then I can see how their mind works and how they process things. That's yoroshiku onegai shimasu. Yoroshiku onegai shimasu. Andre-san, 日本語していますか? Anyway, so I'll present the problem. Okay, no problem. I would like to read it actually. Like proof-based math, I want to get up to that level, but I'm just like I barely started real analysis actually. I'm not in school, by the way. I'm just basically learning on my own. Now the triple. But how are you, Andre-san? How are you? Ogenki desu ka? I actually have to practice my Japanese, actually. I haven't spoken it in so long. I should probably underline this. What else do they have on this menu? Okay, they have shapes. Is there a ruler option? No, this is templates. Nope, we don't need those. Sticky notes, frames, emojis, Do they have rulers? What else do they have here? They have grids, nodes. Well, actually, I would just need a line function. And I think that would be fine, but we won't worry about that right now. Oh, cool. I can do the same thing like I do with whiteboard. Genki Genki. Oh, cool, cool, cool. Hey, hey, Mean Machine Rex. How are you? How are you? Yeah, the reason why Mean Machine Rex is saying uncle is because my other Twitch channel, I'm known as Uncle Talks there. I don't mind being everybody's uncle. I'm all into category theory. Oh, nice. Is category theory like kind of like self-explanatory, like it's just about categories, or is there more to the math than that? Educate me, Andre-san. Educate me. I am interested in what you're interested in, my friend. Oh no, that's not right. Oh, interesting. Let E be a finite dimensional vector space over R. I sort of know what a vector space is. You let B an endomorphism of E. Assume U is not diagonal. Diagonalizable. But its characteristic polynomial is a power of irreducible polynomial over R. So I'm guessing over the real numbers. So the question is, prove the minimal polynomial of U divides the characteristic polynomial of U. Ooh, that sounds intriguing. That sounds like an intriguing. I mean, I probably don't understand, like, I think like the endomorphism part, but irreducible polynomial and stuff, I'm like, ooh, interesting. So you're just trying to like prove, like, I guess like something over the real numbers. Dividers. Yeah, it sounds intriguing, actually. I'm actually curious on like what class is this for, unless it's for a category theory class. Thank you for posting the question. Dad, is that you? No, Famish. Unfortunately, I am not your dad. But how are you doing, Famish? How are you doing? How are you doing? Okay. So, I just want to draw this diagram here. Now, this one, I was a little bit confused. The triple vector product. Because I get this, I get the triple scalar product. That one I understand. I mean, like, visually it looks nice. Because it makes this parallel, like, it makes this whole parallel pipette? I think that's what they call it. Which is really cool, But I am trying to better understand this part. It's hard, right? It's hard, but at the same time, I'm like, that's interesting. It's a really interesting problem, actually. Even though I didn't understand, like, what the question is asking, I feel as if, ooh, it sounds complicated, but pretty saucy. Then this would be AX. Hopefully my handwriting is not too messy in this new application that I'm using, guys. Yeah, that looks really messy. Let's get rid of that. There we go. Nice. That's nicer. I'm eating a hot dog because I can't on an empty stomach. Okay, nice. I remember yesterday you wanted to get a hot dog, but it was too cold. That's Kaylee and Hamilton, right? No problem. If you don't resolve it, don't worry. I think that question is one of the key theorems in linear algebra. Oh, okay. So is it part of linear algebra then? See, this shows how much I don't really know that much. Which I encourage. Yeah, today wasn't as cold. Nice, nice. At least you got your hot dog. Okay, so the way the book describes this, because I have the geometric visual, it's just that I'm trying to better understand what it means. Okay, in the book it says, in this figure you can see the vector B cross product of C points straight up, perpendicular to the plane containing B and C, vectors B and C, right? Now imagine forming a cross product of vector A with vector B cross product C by pushing A into the direction of B with the right hand of your palm. Like, when I think about it, it's like basically yeah, today wasn't oh yeah, I already read that. Got me some root, oh nice, root beer. No, it's not. No, it's not. It's just a soda. It's like practically a soda. Oh, you're an engineering student. Nice, nice. That means you're gaining a lot of like math under your belt. I think like the scientists that gain more math are engineers and physicists. But I think like also like if you're like deeper into the theoretical parts of like science, you probably will learn more math. So we have to imagine, oh, I forgot to write this. So imagine this going into A, right? Is that what that says? Oh no, now imagine forming the cross product of vector A with vector B, cross product of vector C, by pushing A into the direction of B and C with the palm of your right hand. Oh, okay, so basically your thumb is supposed to represent BC and then go... Oh, okay. So you have to move your fingers where, like, you're trying to go towards the thumb, I think. Into the direction of B cross product of C with the right palm of your right hand. The result of this operation, the label A cross product of the cross product of B and C is back in the plane containing the vectors B and C. To understand why this is true, consider the fact that the vector that results from the operation must be perpendicular to the plane containing B and C. If you now cross A into that vector, the resulting vector must be perpendicular to both A and to BXC. Okay. Oh, okay. So we have to think about, like, so for the product to actually have a value, it has to be perpendicular to the actual cross product that is done. Okay. Gotta keep your mind sharp. Right. Gotta keep your mind sharp. Do you know polytechnic schools? I've heard of polytechnic school. I'm not too familiar with it. I've heard of polytechnic technique, but I don't really know exactly what that is. Like, I've heard it like in passing though. I mean, RZ, you can basically like educate me on that if you would like to. I want to learn as much as I can from you guys. Okay, so basically, the vector BXC, you would have to use the right hand rule to get A to move towards that. Okay. Oh, maybe that's why it's like that. Because you wanted to get it perpendicular to it. Okay. Okay, that makes sense. So that's why it's pointing in this opposite direction from B and C, which are supposed to be on the plane. It's the French MIT school. Oh, okay. Yeah, I think I've heard of the Swiss Polytechnic. Oh, that's where I've heard it from. Polytechnic, I've heard it from like when I was like watching a documentary about Albert Einstein. I've heard of the Swiss Polytechnic. I didn't know they have more of them in Europe. That's pretty cool though. Hey, Penn Center, how are you doing? You are also beautiful, my friend. And also, I will give you a shout out actually. We're still working on vectors today. Guys, if you're not familiar with Penn Center, he is an awesome math streamer on Twitch, and he also plays video games as well. But he will also teach you guys like linear algebra and real analysis. So if you got a math question, he's one of the guys to go to. The center of the pen. Yeah, I'm studying there right now. Oh, okay, nice, nice. It must have been very hard to get in. But you really worked hard to get in there. Kudos to you, my friend. Kudos to you. Oh, okay. I'm guessing Andre-san is an acquaintance of yours, Penn Center. Nice, nice. I'm glad friends are gathering in the chat. Okay, so now I think I'm kind of understanding the triple vector product. Okay, that makes sense. Because it was like hard for me to wonder like why was it that the triple vector product is pointing in the opposite direction, but it has to be perpendicular to the actual normal perpendicular vector of the plane. That makes sense. Try to steal my lunch. Oh, poor thing. Poor thing. And he's making pink grunting noises of excitement. Well, at least he's excited. Okay. So I know how to do partial derivatives, but now we have to do 2.6. Oop. Oh, I forgot. I have to click my tablet here. Oops. Nope. Don't go into a different application I didn't ask you to go into. Okay. So 2.6 vectors as... Oh, that is very messy. Very messy. Vectors as derivatives. Yeah, I apologize if my handwriting is very messy, guys. Has anyone worked with the Mito web application? I'm just wondering because I'm so used to whiteboard, and like it's hard for me to actually navigate when the toolbar is like literally like right on the side, but I don't know if I can move it. Let's see. It has to be perpendicular to both A. Oh, to both A and the normal vector cross product. Oh, okay. Let's see. I'm trying to look at it because I see it's perpendicular to B cross C. It seems like you guys are having a real good time in chat. That's good. Let's see here. Because I think you have to just take the derivative of... Let's see. final bit of visualization. So the way they write it is like this. Over t, where dxt and the partial derivative of f, partial derivative of t of x, and if it's like y dt, and the partial derivative of f of y. Okay. Well, that was pretty short of a section. So the Nambla del operator. So I think now we're getting into Calc 3 stuff. Let's see, the fundamental difference between the subspace F is a full vector space, specifically in terms of dimensions. That, like, can a subspace ever have the same dimensions as E? And if so, what does that imply? Wow. RZ is posting like really awesome questions. I can't wait until I can get to your level. Sounds like you're solving very, very intriguing problems. Let's see. It's y plus k hat, and then kz. Yeah, I never solved them, so I'm bad. Nah, no, it's fine. At least you got up to the point where you're actually like learning questions that are actually challenging you. Let's go down. Oh, maybe this web version like cuts some stuff out. Luckily, I brought the book with me, so I actually have the legit book with me. Because I was like, those sections are relatively short. They're not normally that short. Oh, maybe they are. And now we go into the gradient. Just go down. We already did the Nambla. Now we're going to the gradient. Which is, oops. And if you guys would like to join the Discord server, you're more than happy to do so. If the link to the Discord server is not up, just type !Discord. Or it's already up. Nice. My automatic message heard me from the ether and decided to show up for you guys. Yeah, I look at my Discord server as sort of like our own little, like, I guess, like, gathering place where we can, like, treat it as like a research institute. Where it's like everybody's working on their own thing, they're basically looking up stuff, researching stuff, and then it's like, I have this awesome idea, I'll post it. And then all of us can look at it and say, like, what awesome thing did you uncover? And at least it's less bureaucratic than a university. Or a journal board. Oh. Forgot I was on this screen. So I think they give an example. So let's go up here. XE. So we have the equation. (5x plus 2y), and then you take the gradient of that. Since I've read this before, I probably should remember, so I think like the first part is like for x, so it should be, so it'd be 5i, and then the next one would be like of y, so it's like 2j. Yeah, and we got that right. Nice. So let's see. Even though it's a scalar function, it is a its gradient is a vector. Okay. Okay, go up here. Not all subspaces of a vector space E are equal to E. A subspace F of E is only equal to E if it is contained every element of E. Oh, okay. Let's see. If you wish to determine the magnitude of the... Oh, okay. So basically you turn it into a vector and then you can just basically just take the magnitude of it. Let's see, in cylindrical, oh, here we go. In cylindrical... Actually, after yesterday's stream, I began to like write like spherical coordinates like on paper. Like whenever I felt like I had like time spaced out, I was like, okay, time to see if I can remember spherical coordinates. The gradient is r hat over that, and then like that. Oops, no, like that, yeah. And then plus z hat. Okay, now for spherical coordinates. Actually, what is everyone working on so far? Because I know RZ is working on problems revolving around vector spaces. But what is everyone else working on? Or what is everyone else doing? Hopefully you guys are doing something that is helping you feel relaxed or helping you feel productive and stuff that you love. Or even if you're just cleaning up, that's also fine. Let's see. Okay. Partial derivative of phi with theta plus I wonder where these r over 1 over r comes from. Is it like another derivative? Okay. I'm helping organize the new reading group in the math servers. Nice, nice. I can't wait to actually like see those. Well, it's part of the gradient, so I'm like wondering. Yeah, why is it that there's like a 1 over r in the second term of both of them? And why is there a 1 over r sine of theta in the third term of the spherical coordinates? I mean, it's taking the derivative of like those sides. Oh, you're a PhD student, Andre-san. That's cool. What are you getting your PhD in? Do you know how to calculate the gradient? I'm kind of relearning it, because like I've learned this once before when I first picked up the book, but I am sort of like a little bit, I don't want to say behind, but a little bit foggy about it. So I'm just like wondering about like where these extra terms come from. Such as the 1 over r and the 1 over r sine of theta. But welcome, Mavret? No. I'm trying to read your name because like because like I'm thinking port, so like Fort? Mavort? Hopefully I'm pronouncing that right. I'm probably not, but let me know if I'm pronouncing it wrong. I work as a TA in the algebra area. I usually teach linear algebra to first year students. Oh, nice. I think like that's teacher assistant, TA. Unless it's a different term where you're working Andre-san. So where was I? Oh yeah. I was still looking up the gradient. Oh, now we're going into divergence. Teacher assistant? Okay, it means the same. Okay, I didn't want to give you the wrong title. It's like, I've insulted Andre-san. 失礼しました Okay, divergence. There's an... Oh, I'm sorry to read that, Mean Machine Rex. It's best if you don't memorize as a formula. Memorize it as a formula, because then it comes out of nowhere. Comes from nowhere, and it doesn't make sense. If you derive the gradient from the definition of spherical coordinates, then the 1 over r makes sense. Oh, okay. Like also like hopefully I'm pronouncing your name right. Is it Mavort? Is that how you pronounce it, or is it pronounced a different way? I want to make sure that I'm pronouncing your name right as well. But thank you for the advice. Thank you for the advice. I will keep that in mind. Let's see here. Okay, so divergence. I remember divergence was sort of like, I guess their example of a dot product, but like for like I think like a bigger, like more of a derivative version of a dot product. That's how I remember it as. Doesn't matter, just a nickname. Pronounce it how you like. Oh, okay. So Mavort, what are you up to? I guess like, are you like a student, or are you just like a person that's just into like math or science, or just into learning anything? I'm just curious about what's going on your end. And are you working on any projects right now? Or anything like fun or exciting that you really love right now? Or if you're just like cleaning up around the house or just studying. No, I actually have to erase this. There's not enough space here. So let's see. Dot 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 dot. And then okay, now we have more space. That's good. Right here, and then right here, and then K of hat Z. There we go. That's better. I have a master's degree in math and currently unemployed. Aw. Well, at least you have a master's in math, so I'm just glad that you're actually like still like willing to like come on math streams. But like if you're unemployed, like I understand, because like I'm not working either. Like I worked for a job for 5 years. I was just like working as a machine operator. I had a bachelor's in English, and then like after a while, like after working at that job for 5 years, I was like, okay, it's time for me to move on. And then I just ended up leaving that job. And like, you know, I started streaming, like first I started streaming video games, and now I'm streaming math for you guys. So because I have 2 channels. I have this channel, and I also have my gaming channel. I actually like streaming because like it allows me to engage with you guys in real time. And plus, like, I never thought I would be able to be one with the math community on Twitch. So it's like very humbling to actually meet people that are like getting their bachelors, getting their PhDs, you know, and I'm like, wow, they're like going for like higher places. And also they know more than me, so I'm like, oh, I can learn from them too. Yeah, most people here on Twitch do gaming, it seems. Yeah, that's true. Jobs don't define human beings. Right, that is so true. Mean Machine Rex. Absolutely. Absolutely. It's what you do with your life that basically defines who you are and the choices you make. That's why I always try to give positive energy to you guys. Because I mean, like, a career is just a career, you know, like, and you know, like a lot of people really put a lot of emphasis on like, but this is my reputation. Yeah, but you don't really need a career to define your reputation, you know? The point is that, like, you develop a reputation by just being a person that is willing to, like, be around for people when they really need it. Especially the ones that you care about. I mean, even though that I'm unemployed right now, I still do what I can to help out my parents because I'm living with them. You know, like, if they need me for something, then I basically just, like, help them with it. And they're getting older, so I have to actually, like, make sure that I'm strong enough to do the things that they really need, like, you know, carry stuff and all that. Okay, so we're working on the divergence. Okay, so we wrote that down. Oops. You in the same boat as me. Oh, okay. Well, that's good to know, Famish. Yeah, see, you're not alone. You're not alone in yours. And you know what? Like, after, like, I've been unemployed for, like, 2 years. But, you know, like, obviously I had a plan. I basically just saved up my money and, like, you know, thankfully my parents didn't charge me rent or anything. So, you know, like, I was just able to save up my money and just basically just live off the money that I saved up. And, you know, it allowed me to have more time, like, spending with friends. It allowed me more time to actually, like, work on myself. And you know what? Like, if I can develop, like, this channel to make it, like, you know, something lucrative, then that's cool, too. But, you know, whenever you guys drop a follow, it always brightens my day. Because I'm like, wow, we're actually, like, gathering, like... We practically have enough people to, like, start off, like, our own, like, math department in some way. But I'm probably over exaggerating. But you know, like I'm just saying that, you know. I think like one of the dreams I had was basically having a big school where it's like you combine university, high school, middle school, and like elementary school into one whole campus. But a lot of people will probably like have like reservations about that. Because I mean, it would be cool if you just had a campus where all the professors and all the teachers are like literally on campus together, so they can actually learn from each other. And like everyone can learn from the specialist directly instead of having to travel on the bus, like a school bus, to go to the universities. But that's just mainly just a pipe dream. Okay, I guess it's break time. Although it doesn't feel like break time because I was just talking to you guys as well as writing notes down. Alright, so we have like 15 minutes to spend on break time. Because I don't think we have much afterwards. We gotta do like convergence and then curl, and then we gotta do the Laplacian, and then we work on to the problems. But I think like I find with vectors, I think I find them very interesting because like when it comes to divergence and curl, it's used in puzzle. Like, what is that? Like a game or something? I'm guessing it is a game because you just said it. I usually try not to play games like on this channel that much because like I just like interacting with you guys. Like usually like whenever I'm in like this channel, I try to talk about more about like math and physics and like the stuff I'm into. Because it's like for me, it's more like an expansion of that. But I mean, like, you know, like if it makes it more interactive, like, you know. Because usually with breaks, I just like let it a time for us to just talk and relax, you know. But if you guys want to check out my gaming channel, you're more than happy to do so. I'll just type it in here. I just play like gacha games on my other channel, as well as like right now I'm trying to catch up on like stories on like the games that I'm playing, like Honkai Star Rail. I already caught up with Genshin, so I already caught up to Honkai Star Rail. I need to catch up with Zenless Zone and like Withering Waves. I also talk about anime there as well. Like I think last stream, like on my other channel, I was talking about anime with another person in chat, and like we were like basically geeking out on the like anime that we saw like years ago, like Cowboy Bebop and all that stuff. Because actually this book I'm working with, A Student's Guide to Vectors and Tensors, there's literally only 6 chapters in this book. And each chapter contains like 10 problems, and I'm like, that's actually pretty doable when you think about it. I mean, it's not like when you do the book, you're totally a master at tensors and vectors, right? But I kind of feel like, why is it that textbooks, what book is this? It's called Student's Guide to Vectors and Tensors. I could probably produce a title page for you. No. Where is it? There it is. So this is the book we're working on. A guide to students, a student's guide to vectors and tensors. Yeah, I really like this book because the author does a good job of actually explaining things in a very like slow and transitional manner. So that's why I think it's a really good book. It is a think book, right? Damn, that's me on the cover. Oh my gosh. All the students' guides are really good. Yeah, like actually I have a student's guide to Schrodinger's equation and Maxwell's equation. So the Maxwell equation. So I actually want to actually get into those books. Actually, like recently, I actually ordered a book from Amazon. It's not a student's guide book, but it's a book that I think is really interesting. I love books that actually have titles where it's like you don't need this level of math to actually like understand the subject's like mathematical structure. Like one of the books I have, I think it's like Feynman integrals, but with like background of only Calc 2. It's a really good book, actually. I probably will do it with you guys one day on this stream. Like the book I ordered yesterday, it's called I think it's called General Relativity Step by Step. And according to like the synopsis of the book, I even read a little bit of the book in Amazon, and it seems like it's a book that's targeted for people that know at least Calc 2, I believe, or at least high school calculus, that allows you to learn like Einstein's field equations. So, you know, like I think that is like very interesting. Of course, I don't know. I could have bought a book that was like sort of like a book that just throws stuff in there and probably it doesn't explain nothing. That has also happened to me before. But do we have student guides to student guides? That is also a good question. We probably should have like a question on that, like which book is good. All students good. Oh yeah, I read that. I read those two are pretty good. Yeah. I think they're by the same author, I think. Maxwell's Student's Guide to Maxwell's Equations and Student's Guide to the Schrodinger Equation are like a summary of topics. What is the Feynman one? Let me see if I can find it. Let me see. I know it says Feynman path integrals. Feynman path integrals. Because I actually bought this book like a while ago. Oh, hey, here we go. It's this book, Feynman's path integrals explained with basic calculus. I think this book is pretty good. The thing of it is that like I only got through I think chapter 1, because like for me like my attention span is like that of a bug. So sometimes like I get one book and I start reading it, and then I get another book and I start reading that, but I never finish them, especially in math books. Yeah, because according to the prerequisites, it says basic knowledge of calculus is needed and should be adequate to follow this course. We'll introduce Taylor expansion from the scratch, but knowing it beforehand will help. Just a basic understanding will suffice. So I usually like books that actually are willing to go into tougher topics without having to go through the rigmarole of actually like, you know, knowing that you have to know high maths. I mean, it helps, but at the same time, I'm like, there's got to be an easier way to learn this, you know? Or there's got to be a way to get people into it and actually doing the stuff without having them to do this whole wall of like requirements. But you know, that's just my take on it. What do we got here? I need to check them out. He has yeah, the one thing I don't know about like Feynman trick is like you know, the Feynman what was it? I really want to learn the Feynman trick, but every time when I look at videos I get so confused. Cause I know like how do they phrase it? Cause I always remember from the Big Bang Theory like do you know how to integrate x squared times e to the minus x without looking it up? I use Feynman's trick to differentiate under the integral sign. And I'm like, what? What is that? And I try to look up the Feynman trick and I'm like, okay, I'm not really getting where this is going. Maybe I have to slow it down with that. Integrals using differentiation under the integral. Yeah, like that is the one thing that I really want to learn. But every time when I YouTube it, I get kind of lost. What is this? Oh, you actually have a PDF version of this? Oh, there's no bookmark section though. Okay, that makes... Actually, I was wondering if I should get the manga explanation books on math and physics. But thank you for sending this to me. I don't have to I don't have to buy it now. I can actually just like download it. I appreciate that. Lovewort, thank you for sending that. If you like anime and manga and math, you'll probably enjoy it. Yeah, I'll definitely get a look at it. And plus it's manga, so I don't have to, I can read it, focus on reading it, and like look at pictures. It's pretty nifty. Basically, you introduce a parameter into the integral and differentiate with respect to that parameter. So like t, right? So basically you introduce like a, is it like a new independent not vector, variable? Integral is a square of pi. So you use, so you differentiate inside the integral. That I understand, but like you actually add like a new, like you said, a new parameter, right? So like it could be t, it could be like anything. As long as it makes the integral simpler to solve, right? As long as you differentiate within it. Because I think you're supposed to use a partial derivative, right? When you're like integrating inside. Integral negative alpha x squared. Now you differentiate with respect to alpha. Oh, okay. Yeah, because I think like in the first section of the book I just showed you, Feynman path integrals with basic calculus. The first chapter they teach you about the, I think the Gaussian integral, where it's like, I think it's like e to the minus x squared, and then they explain to you that that's like equal to what is it? Is it pi over something? I don't remember. They don't really explain it. They just basically say you have to take it for granted that it's that. Okay, Andre-san, thank you for chilling with us today. It was awesome having you here. Positive vibes to you as well. That gives you the integral x squared. Oh, okay. Could you take that? Okay, yeah. So it wouldn't be negative x squared to e to the alpha, negative alpha times x squared? Then you set alpha to 1. Oh, I forgot the minus. Oh, okay. Yeah, don't worry. I always do that on test too. It's like, I would write everything and everything would look all right, but then I would, yep, I missed that sign. I missed that negative. Don't you hate it when that happens? It's like you're on a roll and you're just writing everything down so nicely, and then you just forget that one freaking sign. It's like when you're coding and you realize, oh, I forgot that one semicolon. But anyways, you always introduce a parameter that does it present. So then, so if you turn x to 1, yeah, and then that would be, huh? Sorry, it's not present. Oh, okay. Imagine a sine of x over x. You do alpha x, and then you take x. So I'm guessing like you basically do u substitution with that. So it's like, oh no, you probably do the derivative of that, right? You take the derivative to alpha, okay? With respect to alpha, okay. Because I had to figure out what WR was. Yeah, so basically it would be like cosine of like x. Like x cosine of alpha x. Right? So then... Oh, okay. Because then, yeah, then you would have the x in front, and then you basically would cross the x out from the fraction. And then you can integrate it by turning it into... Oh, okay. Okay, I think I'm starting to see it now. I think I'm starting to see what you mean. Okay, let me just turn that study timer off, because before we get into the next section, I will be right back real quick, guys. Just chill, relax. I will be right back. Okay, guys, I'm back. Sorry to keep you guys waiting. What did you type in here? Is your name pronounced Tyrion, right? I just want to make sure that I'm pronouncing it right. That might work because of the singularity at... but the idea is that you introduce a parameter, and then when you take the derivative, you simplify the integrand. Okay, so you basically are just using the differentiation just to make your like integrand like much more manageable to work with. I'm guessing that's what you mean, like with the Feynman trick. Okay, so thanks for explaining that. Actually, it made it a little bit easier for me to comprehend, actually. Sorry, it might not work because the singularity... take a look at this. Oh, okay. Let's see what you posted. Yeah, I remember. Like, I remember that one episode because, like, it was the episode where Sheldon and Howard were, like, going at each other's throats. I mean, they probably do that all the time, but it's the one I remember the most because it's basically, like, when Sheldon had to be a professor. I think that was, like, the funniest episode. It's like, I love the little, like, I think questionnaire, like, the little questionnaire, like, one-off they had. It's like, it's like, how would you determine the ground state of a quantum system with no exact solution? I would guess this parameters and enter. It's like, dang. I always remembered this line. Shoot, like, now that I'm actually presenting it to you guys, like, now I'm getting nervous, like, because now I'm starting to forget. Because I haven't done it in a while. Let's see. I will enter its parameters until I find the lowest energy solution. Oh, no. I would guess a wave function and enter its parameters until I found the lowest energy solution. Do you know and integrate x squared times e to the minus x without looking it up? I'd use Feynman's trick to differentiate under the integral sign. Okay. What is the correct interpretation of quantum mechanics? Since every interpretation gives exactly the same answer to every measurement, they're all equally correct, but I know you believe in the many worlds interpretation, so I'll say that. Now, do you think I'm smart enough? No. Like, that episode was just so funny. I actually love that episode. And it's kind of cool because they actually did it back where like Howard actually asked Sheldon some engineering questions. And, like, I got to learn a little bit of engineering from that, too. I mean, just, like, word, like, probably, like, trivia-based stuff. Alright, let's turn on this. Alright, back to work. But thank you for sharing that, Tyrion. Okay, let's get back to where... Oh yeah, I forgot. I took it off. Oh, no, it's right here. Okay, we are still on divergence, so... Let's see... Yeah, I know divergence is sort of like, I guess, like a vector field version of... Well, that's probably a bad way of describing it. I guess it's just like the dot product of like a derivatized version of the dot product. Sorry, I can't type today, but anyways, there's no rule for using the using the trick. It is just thinking about how you can make the integral easier to solve. Yep. Okay, so we wrote that down. So I guess they give an example here. So it's like, example, you have vector A as sine pi of x I hat. So if you were to take the divergence, it would be cosine pi x. So it's going to give a scalar. Let's see what we got here. Now consider to represent the slice through a spherical symmetric vector field with amplitude increasing as the square of the distance from the origin. Oh wait, I have to look at a figure. Where's the figure? Figure 13a. 2.13a. That's 11. Oh, unless I have to click on it. Oh, they don't have the figure? I'm glad you guys like got to unite. It's like, hello, old friend. I probably shouldn't sing that song. I'm thinking of the song from Toy Story. Let's see. Divergence. Oh, okay. So the diagram is up there. I was just thinking it's a different diagram. Okay, 13 point for A. Okay, so it reads, considering it represents the slice through a spherically symmetric vector field with amplitude increasing as the square of the distance of from the origin. So thus vector A is equal to r squared r hat, since okay, and then r hat is equal to, oh yeah, right. This means multiply that by that, and the derivative of, okay. Doing likewise, adding yield was oh, is that why? Is that why the unit vectors are like that? For like for the gradient? Huh. Interesting. And here we go. Now they introduce like the divergence of these coordinates. So cylindrical. Actually, I'll move this up for you guys. Oh, how old am I? I'm 34. I'm about to be 35 this year. But that's not gonna be until the summer. Strange how time flies, right? What about you, Famish, since you're asking? If you don't want to give that away, that's fine. If people say I'm old, I'm just basically like, yeah, I'm old. But at the same time, I don't do it like, I don't use it as an excuse like most people do. Because like most people, they love to use it as an excuse. It's like, I'm old, I don't have the energy to do this. I use it as a way of saying, yeah, I'm old. You're right, I'm old. But at the same time, it's like, I'd rather be like an old fogey that basically just like has fun. While like, you know, like it's not like I'm gonna be trying to be like the cool kids. It's like, I'm just basically like, yo, just chill. Just chill, relax, have fun. You know? That's just me, though. That's just me. I don't know why I thought you were 27. Yeah, a lot of people think I'm younger than my age. Like, I think when people hear that I'm, like, over 30, they're like, wait, what? I thought you were, like, 26 or something. You're 15? Oh, okay. Oh, no. Oh, okay, you're 21. Okay, you're 21. In Japan, old people don't like being given seats on buses. Really? I thought older people like don't mind given a seat. I mean, like a lot of younger people in Japan do that. Like they offer their seat to like someone who's like elderly. I think like when like Japanese people see us in the States and we don't do that, like on our subways and stuff, they probably think like we're just so uncivilized. I mean, Mean Machine Rex, like, have you been to Japan, I'm guessing? Or you have friends there? I still have time for school. Oh, okay. Actually, it doesn't even matter. School is always there. Right. If you want to calculate the unit vectors of spherical coordinates, I mean, hat r and hat phi and hat theta, then you have to collect the Jacobian matrix first. Oh, okay. I did not know that. Thank you, Mavort. Thank you for enlightening me on that. Okay, so it has to be the Jacobian matrix. I don't know why I was like losing words there, because I've heard. I remember that matrix actually. Well, not remember it. I'm familiar with it. I'm familiar with that matrix. X squared. Yeah, I try not to memorize too much, but at the same time, it's like, for me, it's like, if I do memorize, like, some of it, it's not too bad. But I would like to understand, like, where it comes from. Because I remember when I watch I watched the Matt Sorcerer's YouTube channel, and sometimes, like, he would emphasize, like, try not to understand, like, sometimes. Some of the concepts is, like, stop trying to understand everything. Just understand like a little bit, like enough, like the techniques, and then further down the line when you learn more, you begin to see that there is a connection with what you've learned and what you kind of took for granted. Because sometimes I kind of like make myself go into understanding paralysis, where it's like I feel like I have to understand everything, when in actuality I can just like memorize it a little bit. No, I read an article. Okay, gotcha. The online for profit school I'm doing during the graduate ceremony, and old will graduate. Lifelong learning is amazing, but with everything you gotta have money. Yeah, that's the one thing. And like a lot of people that really are excited about AI, they feel as if like, because since AI is coming, They feel as if like now people will actually have a clue and they'll be like, stop working for just the dollar to survive and start actually just working for things that actually give them passion and fulfillment in their lives. Because like this is based on my experience, but like, you know, you guys probably have different experiences, and we'll take that to consideration. But for me, I feel as if you will, like, if you really not dedicate your life, but if you really are passionate about something and like you really put your life, like your energy into it, you will eventually make money off of it. If you want to market it that way. Like sometimes it's intentional, sometimes it's unintentional. If that makes sense. I feel like people get more money the more they're passionate about the actual thing that they're doing, not just to earn a profit though. I mean, it's nice to earn a profit, but that usually comes as a, I guess, a circumstantial type of not validation, but a circumstance. It's based on circumstances. That's basically what I'm saying. Can you write the no, I can't. I've heard of it, I just don't remember what it was. I need to start doing that with content creation. Yeah, like I got into content creation because like obviously for me, I felt as if when I was doing my gaming channel, I realized when I got to affiliate, even though I wasn't making much money off of affiliate, like I would only get like $50 like every couple months, but I saw that there was something that I would see as if like there was a way to actually like do something different with my life instead of just working a job that I was like trudging through just to think that I would need a stable salary, you know? Okay, okay, so that's it for the divergence. Now we're on to curl. This is exciting. And I'm not being sarcastic with that. I actually love learning this stuff. I think for me, it's like whenever I read something, I am so tired of like the books having like endless text, and yet I don't solve problems in the middle of the text. Like, just give me a problem or two, throw me a bone so I can actually like get my confidence up. So I actually know what you're talking about. Okay, so curl. Actually, curl and divergence, I think they're both very interesting because they're really involved with like fields and stuff. I think like vectors are what interests me in math mainly because they're so involved with physics. But then again, vectors are more than just arrows. So curl is sort of like the derivative version of the cross product. That's what I interpreted when I first learned it. Let's see, here we go. Oh, what you guys typed up. Do you know the transformation from spherical to Cartesian coordinates? Like, what do you mean by transform? Do you mean like how to convert between different coordinates? Is that what you mean? If you are given r, theta, and phi, how do you calculate? Oh, like you mean converting? Okay, yeah. Like I actually tried to memorize that. Like it was funny because last stream I was basically trying my best to try to memorize it to actually think of tricks in my head to think about how can I best memorize this so I can remember it better. Use the Jacobian is to figure out how a differential volume dv as dx dy dz into third phi d theta. I'm trying to like read back on what you're saying. I think like since we are talking about the Jacobian, I think the book actually shows a Jacobian here. I could be totally wrong, but is this it? Because there are derivatives in this. Well, partial derivatives anyway. A, X, Y. Since we're talking about it, is this it? If it isn't, like, just confirm with me that it isn't. Because I know it involves derivatives. I just don't know if I'm thinking of the right thing. Is used to figure out how to transform differential elements from one coordinate system to the other. Oh, okay. So it's sort of like well, is operator the right word? Would it be considered an operator? No, right? Because I think an operator just tells something to behave a certain way, right? Like you put some, like basically it's something you put attached to, like say a function, and basically it's supposed to tell that function what to do, right? Or am I getting my terms mixed up? Like dx dy equals r dr, where it's theta. Okay. Try to derive the transformation from. Okay, what is this? Oh. Oh, okay, so it's using theta and phi the same way that I saw it in my book. It is used to change from variables, for an example, in double or triple integrals. Oh, okay. Maybe I'll learn that when I get into linear algebra. Yeah, because I just remember like the transformations between spherical. So let me just like write this down for a second. Just gonna write this down so. Yeah, it reminds me a lot of the cross product. Y to X and then K hat. So I want to make sure that I write everything right. Right, that's correct. I want to explain where r sine theta comes from the gradient. Oh, okay. One, from the illustration, derive the formula for the transformation. Because for me, the only thing I remember is that, because I know x is equal to r sine theta cosine of phi and sine theta sine phi, and then z is equal to r cosine of theta, and then r is equal to x squared plus y squared plus z squared, and theta is equal to arc cosine of z over r, and then phi is equal to arc tangent of x. And I think the unit vectors are r hat is equal to sine of theta cosine I plus sine of j plus sine of theta, and then hat that is cosine of theta cosine of phi plus cosine of theta sine of phi, and then minus sine of, and then this one phi plus cosine of phi. I mean, those are the things I remember from like spherical coordinates. Calculate the length of each vector. I'm not interested in the inverse transformations, just we good this good. Yeah, those are the things I remember from like spherical coordinates. Yeah, I'm actually surprised I was able to memorize this. Yeah, I did too much. Yeah, I know that. Let's see what we got. Okay, now we have the spherical. Now we have the cylindrical. Oops. Now we have the cylindrical and the spherical version of these. So this is 1 over r minus oops then r hat plus ar z minus az over ar. Please tell me I have enough space. Well, technically I can just erase this. It was just me trying to remember things. I don't really need this here. Okay. Let's continue. Let's continue. Then R then AR over phi. Okay. That's a real Lulu. Like, my memory is not the best, but at the same time, I'm like, I give props to like people that could like memorize like equations like on the first sighting. Usually for me, I try to find like patterns, and when I see the pattern within like I guess the setup, that's when I remember it better. But it's usually based on my experience and what patterns I see. But of course in math, that's usually what it is. It's like pattern finding. Oops, that looks really messy. I don't like the way that looks. So r sine of theta. Okay, minus a of theta phi. Calculate the Jacobian, and it's basically the matrix containing all 9 combinations of the derivatives. I should just post AI made content. Are you really into AI, Famish? Because I mean, that could pop off, like AI content. Because like I think there was like a YouTuber, I forgot her name, but she talks about AI, and she's not like a programmer or anything. She just basically like works as a consultant for people that want to get into AI, and like she basically like, I guess like kind of like makes videos about how AI is gonna positively impact our lives. But of course, like, you know, AI could also ruin people's lives, and you know, that could also be a possibility. But for me, I just get sick of like robots taking over, like people fearing that robots will take over and, you know, cause humans to feel like obsolete and something like that. And like, you know, that, what is it? A dystopian view of like, you know, how technology is advancing. Like, I hate that view. I'm like the type of person that really just embraces like what the future's gonna give. But you know, I could be just too optimistic. Not really, but it's interesting. Oh, okay, gotcha. I gotta read what you typed up, Mavort. Calculate the Jacobian, and it's basically a matrix containing all 9 combinations of derivatives. Right? Y is okay. I'm trying to better understand what you just typed up, Mavort. So basically it's like the derivatives of like from one coordinate system to another. Yeah, because I think like I remember reading in this same book that when you change like coordinate systems, like I think it's for like basis unit vectors, you have to take the derivatives of like the partial derivatives of the old coordinate system of the coordinate system you're transforming into to the coordinates that you plan to convert from. It still would take some creativity. The music I made with Sunobot took me a few to try. Oh, okay, I see. You know how to make music? Like science-based content is just cool. Yeah, I agree. Like I love the fact that like, you know, like you know, science, like people are getting into science more now because like it's now considered, I guess, a quote-unquote cool factor. Just as long as the geniuses don't get too cocky in their heads. Let's see here. I'm trying to read, let's see. To understand the physical basis of this result, consider again fluid flow. Paddle wheel analogy. Oh yeah, I remember, like, I think in Divergence there's also a simile here. Or like something to visualize it with. Because I think there's a way to visualize negative divergence and positive divergence. And I didn't think I read that part. Let's see, a vector field decreasing as the square distance of the origin flows. Where is it? I know it's here somewhere. It's gotta be here somewhere. Oh, here we go. Using such tests, it's clear that the locations such as 1 and 2... Okay. That's from a figure on the book. Points of positive convergence flowing away from these points exceeds flow towards, while the divergence is negative at point 3 of this figure. Hence, flow towards exceeds flow away. So let's see here. Okay, so... Alright, let's see. Okay, let's look at the other one here. This other image. Location 6 is obviously pointing in positive divergence. Okay, so when it's positive divergence, it goes from it's like a spout, while negative divergence is basically like a drain. Flowing away and spreading out those locations, the flow lines of, let's see, number 5. They're also pointing away and does spread out slow. Okay. I might start posting stuff and would get me to start learning want to start creating cool edits on physics and learn physics stuff. Nice. So Jacobian. Let me see. I want to see its structure so that I don't mix it up. Jacobian matrix. What does that look like? Why are these images so blurry? So the way the Jacobian looks like, or in this case it will probably like Z. Trying to see how to set this up actually. Actually, when do you learn Jacobians like in differential equations, right? Because I think I remember seeing it like at one point. See if there's an... Are there any examples I can use? Yeah, I would say go for it. Like basically Calc 2? I don't remember learning that in Calc 2. But then again, my Calc class was in the summer, so we had to rush through stuff. So... convert it to R. So then it would be is that right? Oops. Yes, correct so far. Okay. I guess we're taking a small detour into like doing the Jacobian. I guess you just want me to like actually see where it comes from, which I appreciate. Glad to see that you're... Oh, hey, Vemvox. You're looking at some vector calculus. This is some of the stuff that I've been trying to get around my head lately. Oh, okay. Well, hopefully my struggle has become your awesome lesson. But I'm glad that I'm actually writing it right. Mavort. Okay. I mean, that looks about right, right? Hopefully I didn't get the terms, like, mixed up. Because I think, I'll just rewrite what we had before. So that is sine of... and then sine of theta, sine of v, and then sine, cosine of theta. Hello, Dr. L. Welcome, welcome, welcome. Yeah, I'm just basically, I guess we're going into a much deeper topic, I guess, because Mavort is actually teaching me how to, I guess, how not to memorize spherical coordinates, or like to get a better understanding of spherical coordinates and probably cylindrical conversion. But I'm glad I'm actually making your morning. May I ask where you're from? Since you said it's morning, because it's literally like mid-afternoon for me. The ordering is not standardized, but some books use transpose matrix. It doesn't matter that much. Just keep it consistent. Yes, I want you to see where it comes from. Memorizing formulas doesn't make sense. Oh, okay. That's true. That's true. Okay. Oh, it's 3. Oh, that's the same time. So we're on the. So I'm guessing you're from the East Coast. You're from the East Coast of the U.S. That's the same timeline as me. Okay. So we'd have to take the derivative of this, right? So with r, oh, okay. So I'm guessing now we have to write a lot of stuff. Landlock of the good old America, America. so it's sine of, yep. And then for that, it would be cosine and then oh yeah, we definitely got to make this bigger. So then it would be oops, no. Then that's sine of theta. Okay. So then next we go with y. And then obviously y will be the same here. Sine of theta. Oh, okay. Naruhodo ne. So then that would be of theta, right? Yeah, it's theta. So then it would be cosine of theta r, and then cosine. Naruhodo ne. Okay. I getcha. Wait a minute. So fine. Yeah, I did that right. Yeah, I think I did that right. Yeah. I'm like, what am I doing wrong? Okay. Last one is, so that's r, and then yeah, that's cosine. So cosine, right? And then last is z. So z is, so r is just cosine theta. Then next it's gonna be minus sine. Oh, okay. Oh, forgot the r. Right? Yeah. And then technically that's 0. Oh, okay. Now I see it. Okay. Now that's why you want me to do it. Okay. I get your point. Would you recommend a textbook? A textbook you are looking at? Daryl Lynch. I think is the author. If I found the right text here. Yeah, I would recommend it. Well, it's technically not a textbook, it's just a book. Students' Guides to Vectors and Tensors. I would recommend it because it feels as if, like, even though there's a lot of detail in it, it doesn't feel overwhelming. I would recommend reading it and doing the problems from it, because every chapter has 10 problems in it. So it's not overload. It's not massive overload. So I recommend it, yeah. Oh, so I'm guessing that let's see. I want to make sure I wrote this right, the last part. Excuse me, sorry. Yeah, negative sign right there. Oh, hey, Mix the Pick, how is it going? Love living in Eastern. Okay. Do you have an idea where to find the unit vector hat r, hat theta, and hat phi in this matrix? Um, I mean, they do look like them. Like, I will say that for sure. Like, I see them. Like, I see them, like, literally in the Matrix. That's a funny way. That's a funny thing to say, like, within math. Like, if people just only know the movie, it's like, I see it in the Matrix. Yeah, they're literally, like, in the columns. Like, you practically do see them. I just want to make sure I did everything right here, because I feel like there's something off. Yeah, there is something off. I think I did something off here. Yeah, it's because this is not supposed to be cosine. It's sine. And then, yeah, right, yeah. And this is sine. This is sine. Oh, okay. So this is sine, cosine. Yes, but not quite. You need to normalize them, such as length 1. My cursor looks like a little bug. Yeah, because it's supposed to look like a pencil. I'm actually I think you recommended this to me. Was it you, Femvox fan, to recommend me to do Mito? Use the the browser application Mito for, like, writing, because I'm actually using it. I don't know who it was in the chat that recommended me this browser application. No, it wasn't you? Okay. My bad. Not quite. You need to normalize them, such as the length of 1. Oh, okay. So, yeah, because then, basically it's taking the vectors and dividing them up by their magnitudes. Watch this video by Brown. Linear transformations. Actually, I probably should get back to linear transformations. Oops.
What all of the...
Oh, I was actually watching this. I didn't finish it. Jump to... Oh, okay. Well, first, I gotta stop my music for a second. Okay. I guess we'll look into it. 6, 5. Oh, we're actually at the right point. Oh, the sine of thetas in column 3 have to go as well. Let's see here.
Saying is that a two-dimensional linear transformation is completely described by just 4 numbers: the 2 coordinates for where I hat lands and the 2 coordinates for where J hat lands. Isn't that cool? It's common to package these coordinates into a 2x2 grid of numbers, called a 2x2 matrix, where you can interpret the columns as the 2 special vectors where I hat and J hat each land. If you're given a 2x2 matrix describing a linear transformation and some specific vector, and you want to know where that linear transformation takes that vector, you can take the coordinates of the vector, multiply them by the corresponding columns of the matrix, then add together what you get. This corresponds with the idea of adding the scaled versions of our new basis vectors.
And
let's see what this looks like in the most general
second,
where your matrix has entries A, B, C, D. And remember, this matrix is just a way of packaging.
But how are you doing mix the pick? Like, what's the best part of your day so far? And the same to you, Vembox fan. Like, what's the best part of your day so far?
And that second column,
every linear transformation in n space takes that many coefficients. Oh, okay.
Some vector x, y. What do you get? Well, it'll be x times AC plus y times BD.
Let's see, column vectors of the transformation matrix are the transform unit vectors.
You could even define this
Going on
as
a 114 walk?
vector
Nice.
multiplication
That's
when
good.
you put the matrix on the left of the vector like it's a function. Then, you could make high schoolers memorize this without showing them the crucial part that makes it feel intuitive. But isn't it more fun to think about these columns as the transformed versions of your basis vectors, and to think about the result as the appropriate linear combination of those vectors? Let's practice describing a few linear transformations with matrices. For example,
Still morning
if we
for
rotate
you.
all
Oh,
of these
okay, I
90
see.
degrees
Been working on
counterclockwise,
physics, which is a bit
then
fun.
I hat
Oh, I would
lands
like
on the
to
coordinates
engage
0,
with
1.
you on that, on physics.
And j hat
I feel like I haven't worked on
coordinates
physics like forever.
0. So the matrix we end up with has columns 0, 1, negative 1, 0. To figure out what happens to any vector after a 90-degree rotation, you could just multiply its coordinates by this matrix. Here's a fun transformation with a special name, called a shear. In it, I hat remains fixed, so the first column of the matrix is 1, 0.
Oh, hello,
J hat moves over to the
Bamboo.
coordinates 1,
Bamboo
1,
900.
which become the second column of the matrix. And at the risk of being redundant here, figuring out how a shear transforms a given vector...
Let me see. So if you want to calculate hat r, hat theta, and hat phi, then these are just the columns in the Jacobian matrix. You just have to normalize them such that their length is 1. Oh, okay. Like when you say normalized, does that mean you basically turn them into unit vectors? Is that what you mean? Like basically their length has to like equal to 1 in some way? Dr. L, what you typed? That's a tough question. It's super cold here. I've been having fun going outside at night. Oh, okay, yeah, like at the best part of your day. It's been very quiet, and it's been able to hear sound emanating from far away. Oh, okay. Well, at least you're like able to like, I guess, like in a peaceful area, I hope. I mean, like hopefully the noises are not too distracting. If it's very quiet, then you basically have a lot of thinking time. Calculate the length of the first column, then the length of the second column, and then the length of the third column. Oh, okay. Oh, it's by the columns? Oh, okay. Yeah, because I noticed that, oops, I didn't mean to shrink that. Creating a tough ciphers, for, oh, okay. For Phobos. Phobos is just a really good computer programmer. Like, I don't know how, Phobos does it. I'm going to try reverse router firmware. Oh, is there a particular reason? Let me just turn my music back on. Like, what's the cipher for? Is it like to help Phobos with coding, or is it supposed to like give another challenge to this to solve like for like any one of their streams? Just to learn how to do it, and maybe someday I'll find a vulnerability to report to the manufacturer. Oh, okay, I see. Is that what you do for a living? And if you guys really like math and like physics, be sure to drop me a follow if you can. You guys always motivate me and teach me new things, so like I always appreciate all you guys here. Oh, thank you, Dr. L. Thank you. Like sometimes I worry about saying this too much because like, you know, like I know I have to say it because as content creators, like, you know, like we say it just to, you know, remind you guys, because sometimes you guys forget, but at the same time, like I don't want to seem like I'm just begging you for views or anything like that, because actually, like, because of the amount of people that have joined thus far, like followed this channel, I feel I'm more empowered to learn math much more now, as well as physics actually, because like there's so many curious people out there and so many people that know more than me, and I feel like I can learn so much from you guys. Like I know a lot of people that stream math, they like already know stuff, but at the same time it's like I feel as if like there's not enough people to basically say, I'm curious about math, but I don't know enough to be an expert on it, you know? So it's like, I want to be, I guess, that streamer that basically say it's okay to like have a little bit of knowledge in it, because you know you're not gonna know everything, right? And like I know you guys know exactly, like you guys know a lot more than me, and I'm like, wow, like these guys are just so like high end on like, you know, where they're doing, like with math or physics or whatever field that they're in. So, you know, I feel like I can learn so much from you guys. So I'm very thankful that you guys are here and like teaching me stuff. I mean, I don't know if I will teach you guys stuff, but at the same time, it's like, wow, I can learn all this stuff. You don't have to be an expert to enjoy the beauty of math. Yeah, I agree. That's why I call it. That's why I call my channel Math Spellbook, because, you know, like personally, in my personal opinion, if I was a mathematician, I would probably be one of those mathematicians that believe that everything is platonic, even though it probably isn't. Because obviously most physicists would say math is not physics. Math is just a tool we use. But for me, I just feel as if like, because we're able to construct things like, I guess to a point that seems mathematically like coherent, I feel as if like, you know, like why wouldn't the universe be like mathematically consistent, you know, in some ways. Is there a stream category for those with imposter syndrome? I think I fit there. You're in good company. You're in good company, because like for me, it's like I'm making content about math, but I don't have a bachelor's degree in math, right? So like a part of me was like, I shouldn't make this channel, because I was like, I'm not an expert on like things that are like proof based. I don't know anything about topology. I don't know anything about like, you know, linear algebra other than the typical like calculated base, and I barely remember things about matrices. So, you know, you're in good company, Dr. L. You're in good company. Don't worry. I say math is a language humans invent to try to listen to nature. Yeah, I also agree with that too. I'm not going to say you're wrong or right on that, because we don't know if the universe is like some sort of instruction based on mathematics, or it could be just we humans just see patterns and we just are able to create those patterns through mathematics. So we probably just invented math just to explain the patterns that are in nature. Let's see. Okay, sure. Move work. I'll get to it. I'll get to it. Because we still have a minute of break time left, so I'll get to it when we get into our next study session, and then it'll be the last study session. I mean, I appreciate you explaining all of it to me, Mavort. Like all this other stuff. Actually, like, how many sections do we have of the section here? Sorry, no pressure. Oh, okay, that's good. That's good. Like, like in my head, right? Like I felt like you were the teacher that basically was like, "Stop stalling, just do it." and I really want to improve my learning. I really want to improve my learning, and I'd be like, "Okay, I can't let you down. I can't let you down. I gotta do it. I gotta do it." But thank you for reassuring me on that. Because sometimes I don't want to stall. I don't want to stall, and I don't want to make you feel like you're wasting your time on my stream. You get what I'm saying? I know you're doing it for my benefit, so I appreciate it. That's why. But thank you for saying no pressure. that takes a load off of my mind. Because like I feel like basically like I have to do it because the teacher said so. Seems like the streaming would be great way to learn math. So many experts in chat. To set you straight. Yeah, right. Okay. So, I will turn the timer off. Oops. Yeah, if my V2 model just like zooms out and everything, it's just because like my body's off the screen. So I'll just be right back. I'll be real quick, guys. 1 second. Okay, I'm back, guys. Sorry to keep you guys waiting. Anyway, now let's do what we are intending to do. Let's turn all these into unit vectors. Yeah, because it's the same method as turning things into, yeah, because like when you do it with the basis vectors, you basically take the vector and then you divide it by its magnitude. Okay, yeah, like I think I remember that. If I'm wrong, please correct me, please. Okay, so for so the magnitude, I'm trying to why am I blanking out? Oh, okay. So that would be, I mean, this is gonna be a doozy. We'll just call this big R. R squared sine oops, wrong angle. Should be phi plus this is some serious Z fighting with your glasses. Like, what do you mean by that? So if you take the square root of those, sheesh. The face and eye sometimes go through the glasses, rendering top. Yeah, like I set it up that way because originally there was no glare on my glasses before, and because like VTubing, whenever the camera sees my glasses, the reflection, it would cause my eyes to blink constantly. So I had my friend basically have the shine over my glasses so people wouldn't see my eyes blinking over and over. So raise this up. I mean, technically, you can just like factor out from here. So you can factor out this, and then you can factor out I mean, you can factor out the signs. Oh, whoops. Did I write this wrong? I think I wrote this wrong. Cosine. I think this is supposed to be cosine. And I wrote theta again. There we go. That's better. I thought something was funny. And yeah, this is also wrong. Wait. No. Yeah, this is correct. Simplify. Let's see, simplify A times B times C, A, B, and oh, you mean grouping? Okay. Wait. A squared. Ah, right. I see it. I knew there was something that was gonna cancel. I was like, okay, I gotta group this right. Right. So like this, and we still have. 나루호도? 나루호도네? Which is 1. Yeah, so then we were left with ... Oh, 나루호도. Ha. Thank you guys. R. Okay. Oh, okay. That's where the R comes from. By the way, why is there R everywhere in your first column? Right? Yeah, let me take it. Yeah, because that's when I realized something was funny. Let me take a look. Let's see. X and Y. So what if phi? I think it's because I was differentiating them. Remove all the square roots under R. Remove all the R under the square root. Yeah, because we took the del R. Yeah. It cancels more. Yeah, we love it when things cancel. The Jacobian is correct. You want to calculate the length of the first column. Okay, the length of the first column. So then basically we would have to take away. So this should be fun. So, oh, okay. I see now. Ha. So, oh. Right. Okay, so that's where it comes from. Oh. See, this is why I like learning more, because like you get to experience like this mind-blowing stuff, and you're like, oh, I would not have known that if I wasn't curious enough to actually like go into it. Just put an R out in front of the matrix. She'll be right. Oh, I guess I got carried away. Because you said the first column. Yeah, you said the first column. Oops. Oopsie. I got too carried away with that. Remove that part. It makes no sense. Remove the complete matrix. We need to calculate the length of the first column. Oh, okay. Let me see. Oh, hello, PK Zeta. Welcome, welcome. Why can't I move my thing now? Oh, I have to be in pen mode for that. Okay. You tried that R square root on the left, but there's a mistake. We have no R. Let me just erase this then. I guess I did it by row. I think I did it by row by accident. Or unintentionally, I should say. Remove R. But how are you doing, PK Zeta? How are you doing? How are you doing? What was the best part of your day so far? Let's see. Okay, so you said the first row. So the first row. Oh, okay, okay. Huh? Okay, so you said the first column. So the first column is right. Okay. Now I think I'm starting to see what you're talking about. Side of square. Oops. Let's see. I posted Feynman stuff on some of it in the under the general chat. Oh, okay. No problem. Tyrion, thanks for that. No R in the first column. Yeah, I don't see any R's. I don't see any R's in the first column. Two different examples. Oh, okay. That'll be good. I actually will look at that. Cosine. Is that okay? All right. So, oh, this is supposed to be sine of. Oops. Okay. All right. So, I think we can factor out like we did last time. So, whoops. And then boom, boom. And then that's going to be equal to 1, so I'm not going to go through that nonsense again. So technically, it's basically just 1 the whole way. Yeah, because like if you factor this out, you factor that out, then basically you get 1 times, and then you get that, and then that equals to 1. So this technically equals 1. So this equals 1, and then if you do that 1 over that, then basically it's just going to be the same. Well, no. Because then you have to convert like other vectors. Because this is supposed to be the... This is supposed to be the... of the first row. So it's basically the magnitude of the first row. So then the magnitude of the second row would be different. Okay, correct so far. The first column vector r is length 1. Right. So then I'm guessing you want to do the second row, right? Yeah, the second row. That's what I thought. So we'll just put R2 and R1. Make it easier. And yeah, this one is definitely going to have like R's in it. So... Oops. Uh-huh. Okay, at least I'm following your directions correctly this time. Oh no. Wrong thing. I wrote the wrong thing again. It's supposed to be down, not across. So, yeah, so that's correct. This is sine. And then after that is plus r squared sine squared. Okay, now we'll do grouping again. So group that. I'm guessing, yep, you can line these up. So it will be cosine, which obviously will lead to cosine squared plus sine of squared. That. Double check. Yeah, that's correct. And then we are led to here. And then it'll just lead us to, not 0. It will lead us to this. Yeah, it will lead us to that. And that also will equal to, oh, whoops. Wrong symbol. There we go. That matches. And then it will cross out to 1 again. Well, not cross out, but it will make 1. So then we just left with R. Aha. Okay. Alright. Right. And then when you take the unit from that, then basically these will cancel. And then the next one. And then the next one, R3. That will lead us to R squared sine squared oops, that one, plus sine, oh whoops, no. That's what happens when you write so much. You forget what you're writing about. Okay, and then actually let me just bring this up a little bit so you guys can see. Now we're gonna have to factor out stuff. Yep, we know what to factor out. So these, boom, and that's gonna be 1, and obviously this is going to boom. Okay. Alright. Okay, now I see it. Okay, so now I'm just trying to go back and see what it is. Okay, so spherical. Okay. Right. Oh, okay. Like, I'm starting to see it now. Yeah, this is 1. Yeah, this is 1 because there's no R's. This has an R in it. So this, yeah, cylindrical. Okay. Okay. So I guess I have to rely on this method to actually, like, I guess, remember the coordinates better. But I think I'm starting to see it. Yeah, because, like, this one's like, yeah, this is right here. Oh, okay. Now my mind is blown. It's blown, but at the same time, it's in a good way. It's in a good way. It's like very inspiring. Let me take a look here. We now we have one R, and these are factors. These are factors in the gradient. Yeah, so I'm going to look back at the gradient that I wrote. Where is it? This is divergence. Here it is. So this is R. So this is this is cylindrical. This is spherical. Okay, so that's where that comes from. And let's look at the divergence. R squared. Okay. So there's the signs. But that's mainly only for, like, the gradient, right? Like, for the... Because it seems like it's somewhat similar within the divergence. But at the same time, it's like, I think there's, like, other stuff involved. So, like, when it comes to the divergence and the curl, right? Is it, like, a different... Like, not a different method, but I guess it's sort of like... Is there, like, an additional thing you have to do to actually, like, get those, I guess these factor terms here? Or is it just the same process? Because I don't want to assume it's the same process, because they look remotely similar. It's just that I feel like there's an extra step that I probably haven't done for this process. So we were on curl, right? Yeah, we were on curl. I'm trying not to lose track of where we were, because, like, I think after curl we're going to do in the Laplacian, and I think tomorrow we're going to do the questions involving this chapter. Oh, let's do this, carry this up. I was just focused on the gradient. Oh, okay, gotcha. But thank you for showing me that, Mavort. Like, I keep having to think about your name a little bit more, because I'm trying to make sure that I pronounce it, that I'm used to. But thank you for showing me that. I appreciate that. And I thank you for being, at least trying to be patient with me, because, like, I wasn't following your instructions to the T. I apologize for not following your instructions, like, clearly. Because I'm so used to, like, people, like, telling, like kind of, like, shouting at me, like, when it comes to, like, following instructions, because sometimes I don't follow it to the T. Because I think I know what I'm supposed to do, but I don't do it correctly. Okay, so for curl, how do we think about curl in this book? Okay, to understand the physical basis for this result, consider again the fluid flow of paddle analogy. Imagine the forces on the paddle wheel being placed in a field. Let's see. The center curvature is well below the bottom of the figure, and the spacing of the arrows indicates that the field is getting weaker with distance. I'll probably just pull this down for you guys so you can see it, what I'm reading. I probably should have done that to begin with. Alright, so it says here Alright, so we have this image here. We should probably zoom in a little bit more. There we go. Okay, so we got a weaker field, downward field, stronger field. So, weaker push, the right, stronger push, upward push. Offsetting components of curl of vector A. Let's see, the center of the curvature is well below the bottom of the figure, and spacing the arrows indicates the field is getting weaker with distance from the center. At first glance, it may seem that this paddle wheel would rotate clockwise due to the curvature of the field. Since the flow lines are pointing slightly upward at the left paddle, and slightly downward at the right, but consider the effect of the weakening of the field above the axis of the paddle wheel. The top paddle receives a weaker push from the field than the bottom paddle, as shown in figure 216. Okay. The stronger force on the bottom paddle will attempt to cause the paddle wheel to rotate counterclockwise. Thus, the downward curvature of the field is offset by the weakening of the field with distance from the center of curvature. And if the field diminishes as 1 over r, the upward downward push on the left and right panels is exactly compensated by the weaker, stronger push on the top of the panel. The clockwise and counterclockwise force balance, and the paddle does not turn. The curl at this location is 0. Oh, okay, I see this. Alright. So the curl is 0, like at the center point, like right here. Well, not the center point, but like these paddles here. Let's see. The curl at the location, this is 0, even though the field lines are curved. For this 1 over r field, the curl is 0 everywhere except the center of curvature, where the singularity exists and is handled using the delta function. Alright. Okay, we got the Laplacian. So I'll just drag this back up here so I can just take more notes. Alright. 2.11. Hopefully you guys are enjoying the math. And maybe a little bit of the physics. There was a little bit of physics in that analogy, actually. Let's see. Once you know that gradient of a scalar function produces a vector and the divergent operations on vectors produce a scalar, it's natural to wonder whether these two operations can be combined in a meaningful way to turn out the divergence. Yeah, and they can. So now we got to do the Laplacian. So the Laplacian is practically like the second derivative of a vector. So we have to write, so its general form looks like this. And see. Okay. Okay, that's its general form. Wait, where's my mouse? There it is. So the Laplacian operator is this. Yeah, I didn't learn what operators were until I started until I did a course on quantum mechanics on Udemy. I was like, "What's an operator?" I've been hearing that a lot, and I looked and I had to look it up, and I was like, "Oh, okay." So an operator just basically is like kind of like a little like mathematical operation that tells something what to do or what operation to take. And they really love to give the spherical and they really love to give like the different coordinate systems, which I don't mind because like it's probably better for me to know these coordinate systems. Spherical. Probably bring this up a little bit. Spherical. And just erase that. Right, okay. I thought I missed something when I was writing. Whenever I write like equations down, I keep thinking of the scenes that I like to rewatch, like from like either shows or movies about geniuses, like writing equations. Like I'm remembering the scene from like National Geographic's Genius of Einstein, when he was just trying to figure out how his theory of general relativity works mathematically. Like I always remember like when he was like, it shows a scene of Einstein just working on a board in a classroom while David Hilbert is just basically just like writing on like the window in his house, like trying to figure out what the mathematical form of the general theory of relativity would be. Deriving the Laplacian and spherical coordinates will be a lot of work. Maybe here it's okay to skip it and just use the formula, right? Like, would you recommend the same thing with the curl and the divergence? I mean, nobody memorizes the formula for the Laplacian of the spherical coordinates. Oh, okay. Like, do you use this often? Like, I mean, do you use like a lot of math in your like in your work, Avort? Because you're very knowledgeable. I will say that for sure. I mean, you know more than me, so like I'm guessing you use this a lot. Like, I mean, like math. in general in your daily work. So I think the Laplacian is the last thing we cover in this. Yep, now we got the problems to do. Wait, how many problems did they give you? They give you 12, right? Yeah, it looks like they give you 12 problems to do. Okay. So, 2 point. So I think we're gonna work through the problems and continuing on till tomorrow, because this will be the last study session, and then tomorrow we'll probably work out the problems. No, it's used often in physics. In physics, you often do calculations like that. Math, on the other hand, is more about proofs. Yeah, that's true. That's true. I think with physics, like, the questions I struggle with sometimes is mathematical derivation. Like, you have to derive something from, like, I guess, like a mathematical idea, but it seems like it's more like a math proof type of question, and sometimes I miss those. Like, I think it's like, one of them would be like, what is it? Like, prove that the cross product is, like, the magnitude of the vectors, times the sign of the angle between them, times the normal vector n. Like, you had to prove that. Like, I remember reading a question on that, like, I think in a physics book I was doing. For vector A and vector B, plus 4. Actually, I don't know if I have to save this. Maybe I'll just... save as a PDF, save as to Google. Let's change the thumbnail. Nah, it's... find the scalar product. And the angle between A and B. It's getting dark in here. There we go. I just had to turn on the light in my room. turn on the life. Turn on the life in the room. Okay. I don't think this one is too hard. So they wrote it right, yeah. And then B is J plus 4K. Okay, take the scalar product, so that shouldn't be too difficult. Oh, whoops, no. Why am I writing an I in there? It shouldn't be there. Times 1 plus -1 times 4. 0, 2, and -4, which turns out to be -2. Okay. Alright, next, find the angle between them. So, dot product here, and then the magnitudes, and then cosine of theta. Then we would have to do theta is equal to the arc cosine of, yeah, because this is a, they're all scalars. Okay. Wow, that looks so messy. There we go. That looks nicer. Okay. So actually I'll raise this up. There we go. And the magnitude of A is this equation works for planetary orbits, and this one is here. That, like, usually I would remember like scenes where like geniuses would be writing on the board and they would be saying, they would mumble something about the work that they're doing. Like, that's usually how I am sometimes, but I would say it from the scene that I saw it from. So this would be 9, 4, and 1. And then to total, that would be 13, 14. 17. So the angle between them, and luckily I have my calculator. I remember that last time I not yesterday, but like one time I forgot my calculator and I didn't get it. Luckily I wasn't handling like massive math heavy work that time. Yeah, there's no negative under there, so. Okay, so we got the angle, and we got the cross product. I mean, not cross product, the dot product of that. Okay, cool. Raise this up like that, like so. And if vector J minus plus and K, well, actually it should be make it a capital K so we don't get confused. Okay, do it like this, like that. Let's see, find the vector L that equals the cross product J and K. Also, oops, show that L is perpendicular to both J 2k. Okay, cross product time. Oh. Yeah. Guess we're gonna have to continue that tomorrow. But we got one problem done, so if you really want to suffer, you can generalize spherical coordinates in n dimensions, calculate the Jacobian matrix and gradient and Lavoisian. That sounds fun. But thank you guys for joining me today. For those who basically, for new people that gave a follow, thank you very much. I really appreciate it. And for all you guys that are still at the chat, or if you guys are lurking, thank you for lurking. If you guys like the math content as well as the physics content, be sure to drop me a follow, please. Like, it really helps out the channel and also helps inspire me more to like do more of these math vlogs with you, as well as physics vlogs, VODs, I should say VODs. If you had to go early and you missed out on like the last couple of minutes, or you missed out on the beginning, thank you for the follow, Mavor. Thank you very much. I appreciate it. Yeah, if you missed any part of the VOD and you want to catch up with it, I will be uploading these VODs onto YouTube, so don't worry, you won't miss it. You'll be able to catch it on my YouTube channel, so I will put my YouTube channel in the chat. So yeah, you guys can catch it. You guys can catch it on YouTube if you want to like review back and everything like that. Yeah, and also if you guys want to follow me on my other channel, my gaming channel, Uncle Talks, you're more than happy to do so. And I think that's it for today, but thank you for joining me today. And always remember, guys, everyone is precious. You guys just as precious as everyone else. And I will see you guys tomorrow on Wednesday for the last stream of the week. So take care, guys. Bye-bye.